covering timely and apt topics as wide-ranging as new age technology, fitting out legacy sewage treatment processes, securing India's water future with path-breaking tech, climate-proof urban innovations, next-gen citizenry spurring water solutions, remediation of water body systems, water-based green fuels with a competitive advantage among other need-of-the-hour topics. Moreover, our 3-day endeavor here will aim to bring together a very select audience comprising producer circularity and sustainability heads and CSR, ESG and EHS leaderships, public policy, regulatory, legal and compliance teams, QA/QC experts, TQM, QMS, lean manufacturing and Six Sigma certified experts, performance process, operations and manufacturing excellence professionals, and plant heads, digital and business transformation specialists, change management professionals, technology providers, secretaries of municipal corporations, pollution control boards and urban local bodies, amongst others. I'd like to begin with our first session for the day. Our first panel is titled Role of Cutting-Edge Innovation in Reinventing Industrial Sewage Treatment Processes. And I would request each and every one of you, I invite you all to kindly join me now as I welcome our dignitaries, our esteemed panelists up on stage. I would have a request for all of us who are seated here to participate actively throughout this panel, which will be very engaging. And the first thing that we can do is ensure that we are as close to the action as possible. So a request to all of our visitors, delegates who are seated at the back, if you would perhaps like to take a free upgrade that we are giving you just for this morning. You are now getting this upgrade from economy to business and first class. Our seats are vacant and yours for the taking. And while you do that, if you can also switch your cell phones to silent mode so we do not disturb all the proceedings on stage. We will be obliged for that. Thank you so very much. And now, please join in with a warm round of applause as I take the pleasure of inviting our esteemed panelists up on stage. Firstly, please join me in welcoming our moderator for this session, Dr. Ajit Salvi, former Deputy Chief Engineer, Sewerage Operation, Mumbai Municipal Corporation, and he's right up here on stage. Welcome, sir. And Dr. Salvi will now welcome all our panelists here in our midst. We would like to welcome Ms. Rupali Deshmukh, Country Manager India, IBL Swedish Environment Research Institute and CEO IBL India Environmental R&D Private Limited. Welcome, ma'am. Ladies and gentlemen, thank you. We would like to welcome Mr. Ajit Khandeshe, Managing Director, Quang Environmental Solutions India Private Limited. Welcome, sir. Thank you for joining us. We would like to welcome Mr. Kamal, CEO at Daikin Access India. Thank you very much, sir, for joining us. I'd like to welcome Dr. Milind Kulkarni, Director, Prachi Services Inclusive and Prakruti Research Foundation. Warm welcome to Dr. Milind Kulkarni. And we will have a very special moment in a short while as Dr. Milind Kulkarni has got a present for all of us that you can see it up there. Yes, that will be shared with all of us. I'd like to welcome Dr. Prashant Bhave, Professor, Adjunct VJTI, Mumbai. Let's have a big round of applause. Yes, indeed. Now that section is the most lively section here. If we have a prize, we're going to give it to them, ladies and gentlemen. You also are invited to participate. All you need to do is get your hands together and let's welcome Mr. Girish Bhave, Director Sales South Asia, Veolia Water Technologies and Solutions. Welcome, sir. Thank you so very much, our esteemed panelists, for joining us. Now, before we commence with this panel discussion, friends, we have a little surprise, as we told you. We have Dr. Milind Kulkarni, Director of the Prachi Services and Prakruti Research Foundation, and he has a research book that he would now like to share with all of us, and we are looking forward to that book being unveiled and presented to all of us. And we would like to do it at the hands of Ms. Rupali Deshmukh, and our moderator, Dr. Ajit Salvi. Can we have both of you step forward, please? And may I invite Dr. Milind Kulkarni to bring the books forward as well. Recommended to each and every one of you, and all of these books will be available on every bookstore that you would like to purchase from. A fabulous moment indeed. Thank you so very much to all our esteemed panelists. I believe Dr. Milind Kulkarni will talk about this book in a short while from now. But right now, we would like to start off with a panel discussion on the role of
the stage. So these are the discussion points we will talk about with our panelists, and then later on the floor will be open to the all participants to throw the questions, whatever you want. All these are really experts having full the experience from the theoretical side, from the practical side, and all over the globe. So that is what expected. So I just go back to my seat and I am starting the panel discussion. Thank you. So welcome all with a round of applause. Okay, so with this description and with this inauguration part, or with, I can say, brief introduction about the panel discussion, I am starting the question, and the first question to the Professor Bhave. So, to be very frank, there is a domestic discharge or domestic sewage are known to everyone. But
we need to understand what's the basic or the fundamental difference between the domestic wastewater, that is what we normally term it as the sewage, and the industrial effluent. Sewage, when we call about it domestic waste, which we all generate, is more or less liberal in nature, because our activities are known to the technocrats, and its technology is more or less known to everyone. Like we put into that the human discharges which come over there in the form of the organics. There are inorganics which are contributed into the sewage or the wastewater in the form of detergents, or in the form of soap, or in the form of whatever cleaning solutions we keep on using. So these are the inorganic and inorganic substances which get into the wastewater or the water, and it turns it into the wastewater, which we call it as the domestic sewage. More or less this remains same with plus minus characteristics with little deviation globally. But when it comes to the industrial wastewater, there is always a challenge, because it varies with the industry. Depending upon the chemical industry, it will change. If it's a fertilizer, it's going to change. If it's an engineering industry, which is talking about the electroplating, the characteristics are going to change. If it's a food industry, again, it's going to change. So there is a huge amount of variability among the characteristics, and that creates a challenge for everyone. So conventionally, all these industries used to exist, and we used to work upon these industries, taking into account the characteristics and then planning, designing a plant according to these impurities which are added. I'll give you the one very small example. We have certain characteristic features which are there for the wastewater. One of them, everyone is aware of it, because this is all talking about the water wastewater. BOD. It's an organic substance which demands for the oxygen. Another is called as COD, which is a chemically, when we measure it, the oxygen demand. These two are having a huge variation if I am talking about the food industry as compared to the domestic sewage. The variation is large. When it comes to a chemical industry, the COD turns into thousands. Now, this water needs to be treated, because the treatment is required, as Dr. Salvi was telling, that it's a challenge. Yes, it's a challenge now. Challenges from the side of the recent challenges from the side of the sustainability. We need a sustainable environment. And then the policies are demanding very high standards of effluent to be treated. So when it comes to that, now industrial waste, when it comes to, it's a function of the volume. And day by day with our growth, we are increasing these volumes, because we are growing. We are growing very fast as a globe. So when the volume is increasing, And such kind of challenges in the form of impurities are there. We are searching for a technology which will give it to us with minimal of harm to the environment. And that is biggest challenge with the newer kind of additions to the industries and the industrial waste. And we are searching for the solution. All these 500 odd stalls over here are talking about how do we remove the impurities from the industrial waste. Everyone sitting over here are the experts from the various impurities to be removed. So the challenges are in the form of
Yes, sir.
the characteristics
Agree.
and the volume.
Yes. If the chance is given, Bhave sir can take one lecture on that. So definitely. So I have to restrict, I have to intervene. So we will start the lecture of VJTI. Anyway, sir, so the bottom line is what? Basically characteristics are uncertain. Unlike say when you talk about the sewage, domestic sewage, some we are well aware about that. What is happening or what are the inlet parameters. And same thing is not applicable at industrial side. So that is a big challenge. Anyway, so that is a single highlight I am just talking about. Now with this background, there are lots of restriction or lots of limitation, or we can say lots of the pollution control board, they are imposing some sort of a control on that. So with this particular control activity, I am just going to the Dr. Milind Kulkarni. Sir, what are the discharge standard prescribed for the industrial effluent by the pollution control board? See, I am not expecting all discharge standard, but I am just trying to highlight what is the difference or what are the discharge standards they are prescribed. That is what expected.
Generate profit, right? So this, according to them, is a compliance expenditure. But because there is compliance, they have to treat that. So coming back to the question, compliance means what? Standards. So as we are evolving, as you know now India is the 5th largest economy in the world. And if you compare the purchase power parity, we are already 3rd. So standards are also evolving, right? So when I was teaching in SP College of Engineering 15 years back, I was teaching only about effluent standards, IS 2499, that's it.
So
that's it.
I think my question is really right question I selected. Yes, good.
So the standards are there, like there are 3940 parameters, pH, COD, BOD. So if an industry is generating 10 KLD, they also conform to the same standards. And if an industry is generating 100 MLD waste, then also the standards are same. So there was no consideration about the mass of pollutants you were emitting. So these standards were there. They were called as IS 2499. Now, as I was telling about the evolution, they are called as the standards under Environment Act 1984. And they are categorized into 3 categories. So the first category is called as class A, and it is equivalent to IS 2499. And they depend on the mode of disposal. For example, if you are disposing in inland surface water like river, lake, etc., the standards are strictest. Second mode of disposal is public sewer. There the standards are relaxed. Then it is on land for irrigation purpose. And the fourth is coastal areas. Okay. So these standards are given all right, but Pollution Control Board can override these standards. When they give consent later, they can modify that. So it is not necessary that only these standards are to be conformed. So coming back to that, as Dr. Salvi was telling, we don't have time to list all these 40 standards. So I will just give you an example of BOD, for example. So BOD, if you are going to dispose your industrial effluent into river, the BOD should be brought down to 30 milligrams per liter as per IS 2499. If you are disposing in public sewer, because after public sewer you are again going to treat it in municipal sewage treatment plants, the standards are relaxed. It is 300 milligrams per liter. If you are disposing it on land for irrigation, gardening, etc., the standard for BOD is 100 milligrams per liter. And again the marine coastal, like Bombay for example, has the advantage of sea. So you can dispose after treatment to sea water. There the standard is 100 milligrams per liter, right? So that is about the effluent standards. But as I told, there are now different authorities. When I was teaching, there was nothing like National Green Tribunal. Now National Green Tribunal has come out in the picture, and they have made the standards even more stricter. Particularly now what is happening is this treated sewage or treated effluent, it is no longer getting disposed. it is coming in your flat residence, because we can't have the luxury of BMC. Dr. Salvi was treating the water at Powai, and the water comes after so many expenditure to your house in Bombay, and you are just flushing and 20-liter water gone. That is no more available now, that luxury. So yeah, so therefore what the National Green Tribunal has done is, they have further made the standards stricter. So what is the BOD? You can imagine what BOD should be there. It should be less than 10 milligrams per liter, right? Suspended solid should be less than 10 milligrams per liter. Earlier there were no strict standards for nitrogen and phosphorus, which are causing eutrophication of lakes. You go to Powai, is it lake anymore? No, because nitrogen and phosphorus due to domestic sewage is disposed. So what National Green Tribunal says, the nitrogen should be brought down to less than 10 milligrams per liter. Phosphorus should be brought down to 1 milligrams per liter. So coming back, are we having those technologies? So now, like Mr. Girish Bhave is there from Veolia.
Definitely, yes sir, I agree.
Membrane.
So for that purpose, experts are there from the technology side.
Yeah.
But I would like to conclude your answer that you are saying that definitely discharge standards are given for the various purposes based on where it will be discharged and all. Good notes can be drawn based on the answer given by the Dr. Kulkarni sir.
So just, yes, 2 minutes I will take. So just I have covered A category. Category B is for like waste generation standards. Like everybody is talking about sustainability. So no more you are allowed to generate whatever water you want. So now the government has come out with, per ton of your production only you can create so much wastewater. So they are called as generation standards, category B, and they are there for 11 different industries. And last, category C, now as I was telling, people were just emitting air, water, etc. No control on whatever flow rate. Now government has come out with the load standards. They say per metric ton of soap crude, you can dispose only 6 kilograms of BOD. So that is called as load standard. So I finish it here, sir. Go ahead.
Definitely I will give chance for the second round, sir. No issue. But really speaking, after discussing about the difference between the say domestic sewage and effluent from the industries, sir has nicely given what are the standards prescribed by the Pollution Control Board and how the authorities are controlling that. So definitely, to be very frank, say development cannot be at the cost of the environment, definitely. And that is the reason some standards are required, some regulatory bodies are required. So with this, say whenever the big industries are there, they can set their own say ETP. Okay. But when you talk about the say small industrial estates are there, and different industries are there, they are producing their own, or their processing industries are there. So as a result, there is a provision of what? CETP. So with this CETP, as a common effluent treatment plant, Mr. Ajit Khandeshe, I think he is the right person, and he will talk about what are the challenges faced while designing the CETP.
Common effluent treatment plant, Dr. Prashant Bhave has already was informing that there are various types of effluent generating industries. The characteristics are very different, and when it becomes small industries, the small industries does not have the capabilities on the technical for the design or the execution of the effluent treatment plant. So Government of India has come up with solution early 90s that the common effluent treatment plant should be there. So the small scale industries which are discharging less than 25 cubic meter, they become a part of a common effluent treatment plant. The major industries will generate their effluent to the standards which is the discharge standard, but the small scale industries, they can discharge at the COD around 2500, BOD around 1000, flow less than 25, so they can have a common effluent treatment plant. But again, there are some mischief happening that major industries sometimes discharge when their plants are upset. So there are common effluent treatment plant working good. Actually on paper it is really a good solution, but in operations it becomes a very big challenge. With this, I think this was the cover I am supposed to do. But there is a lot of challenges in designing also. In normal case, nowadays, again, zero liquid discharge has come in picture for the common effluent treatment plant. Probably that is the second question I need to answer. So on the technology front.
Yes.
Yeah.
Thank you. say after discussing about the CETP and all, I would like to ask, go to the Girish Bhave, having expertise from the membrane, he is having lots of expertise from the membrane. My question is what? That membrane was very much, or it was implemented in industrial sector. Domestic sector, it is a comparatively new one, comparatively. So my question is what? Do you see future as a membrane technology or a membrane solution for sewage recycle, similar to like industrial effluent?
Yeah, thank you, Dr. Salvi, for that nice question. In fact, I think all my co-speakers talk a lot on the industrial side, and well, membrane technology predominantly is well established in the industrial effluent, whether it is a tough to treat effluent or a pharma effluent, or whether it is a refinery effluent. Membranes have been used predominantly. Now I see really a very high features typically on the sewage side. I mean, sewage recycle is one of the sweet spot. We call it as one of the sweet spot when it comes to the membrane industry or a membrane application, for obvious reasons. When you try to do a sewage recycle, ideally we are trying to achieve the highest reuse quality. And we always try to give emphasis as sewage recycle for industrial reuse. So once we do that, ideally we are creating fresh water free zones. What I mean by that, I'll give a very small example. Here itself in Mumbai, we had done a project in a company called RCF, which has really witnessed one of the forefront in the innovation. We have supplied our MBR technology and taking raw sewage directly from the Ghatkopar sewage pumping station, passing through a MBR technology of the Veolia, followed by an RO plant. Thereby, the industry itself is becoming self-sustainable, and fundamentally, close to 30,000 families living within the Chembur vicinity in the city of Mumbai are getting uninterrupted fresh water. So, ideally speaking, this is the way I look at for the future of the Indian industry, specifically for the sewage recycle, that membranes really are creating a good impact, and industries, ideally speaking, the way already there is a GR which is being published ideally for the power industry, that power industries nowadays, if they are located within 51-kilometer radius, they are mandatorily supposed to take a treated sewage. I think something similar to that, there has to be some guidelines should come for all the industries, by virtue of which actually we could able to maintain a water eco balance in the system. All the industries, technologies are available, and within Veolia ideally, or maybe other guys also, everybody has done a lot of membrane research, and we have supplied lot of plants. RCF is one example. Similarly, even in the government, for that matter, Navi Mumbai Municipal Corporation, they have already set an example under the Amrut scheme. They are the first one who implemented the first tertiary treatment plant projects in Maharashtra, 220 MLD plants, and the recycled water subsequently would be supplied to the Thane-Belapur industrial area. So I think these kind of concepts, I see a very bright future. Apart from that, already sir, when you were in MCGM, I think the Mumbai Municipal Corporation and IVL is anyway there. The two largest plant, well, I would say one of the largest greenfield in the world is 500 MLD MBR already is under execution for the city of Mumbai for Worli. The same with 360 MLD. So already I think the inculcation has already started. Penetration is going on. Probably I think we need to replicate more of this value story to the other parts of the states, and how we can increase beyond reuse. I think there is a potential even for the discharge when you have the space constraint, when you have the retrofit issues, where a lot of STPs are old retrofits which will come from the retrofit. I think there's a nice potential, I feel, and the future is bright for the membrane guys. That's why I would like to conclude. Thank you.
Thank you. So you would like to highlight that now that membrane era will start. It already started, I think. So
Yes, sir. Thank you.
With this, now I'm just moving to Mr. Kamal Tiwari, having the expertise in decentralized STP. So my specific question is, what are the challenges in STP implementation in India? And on that particular light, how you see decentralized STP market evolving in India? Should I repeat the question? You heard? Okay.
Yeah, you can repeat the question.
What are the challenges in STP implementation in India, and how you see decentralized STP market evolving in India?
So thank you, Dr. Salvi. It is, I think, very interesting question to look at the overall context of how decentralized STP or STP scenario as such in India, because we are dealing with a very complex situation. We have unaware user. If you look at on a broad basis, the users who are generating that wastewater are not even aware that that water can be treated and it can be reutilized, or it is doing harm to them and to the environment as a whole. So that is unaware user is one side of the story. Then you have multiple alternatives being promoted in the market, which are, let's say, some of them are doing good job, and then are many alternatives which are not safe for environment. So those are the scenario. And there is a lack of complete cohesive standard in the smaller STP market. And similarly, those waters are basically now, because there is big consumption of soap and grey water generation, so it spoils the whole pond and the overall old ecosystem. So it is doing a lot of harm. And then there are maybe all kinds of alternative use for black water treatment, which is finally going to groundwater. So it's a complex situation. But from there, now under Swachh Bharat Mission, Amrit and many other government schemes, there are large scale implementation happening. And I'm very happy to report to you, as of 1st October 2024, PIS has come up with a standard for packaged sewage treatment plant in India. Daiki was in forefront of forming that standard, because we felt that this market need to be organized from technology viewpoint, from skill development to manufacturer's responsibility. So that standard is now there, and Daiki would be the first one to maybe go and maybe voluntarily apply for that standard. So there is IS standard which is there now. And decentralized market, I would say, is evolving very fast. We entered the space in Daiki with Jokaso, and fortunately we had a long experience of Japan, where this whole system is very well regulated under the Ministry of Environment, from defining the technology to certification of product, then maybe responsibility of the manufacturer and operator and desludging operator. So same thing is evolving now here in India, and we have now a good case. So it's evolving well now.
Yes, agreed. So in view of recycle and reuse, definitely decentralized STPs are, say, it is welcome. And the good news is what? Already standards are established, and BIS has given already published the standards. So that will be very much helpful for designing the decentralized STP. So after discussing a lot about from the Indian side, let us have what is happening all over the world. So definitely everybody is very happy to listen Rupali. So my question is what innovative technologies are emerging in industrial wastewater treatment, and how is the Western world contributing to their development? Very specific question, please.
Thank you, Mr. Salvi, for the question, and thanks for inviting me here. So, you would like to hear what Western world status with respect to wastewater, more specifically industrial wastewater. So, I will narrow down because I come from Sweden. Sweden is in a forefront when it comes to wastewater or any environmental technology. We stand number 1 on innovation index. We have covered all the SDGs in Sweden. So who is better to share a knowledge for India if you have a Swedish partner? I can brag about it. Mr. Kale is here, and their Veolia technology has been evaluated by my institute IVL. And now, as he mentioned, that the biggest STP having an MBR would be Worli. Till now, it's in a Henriksdal in Sweden. So we brag that we have the biggest MBR, but in a few years, India will brag that they have the biggest MBR in Worli, and I'll take a glamour because I'm working on that project as well. So coming back to the industrial wastewater, that is the focus. It is very different because in Sweden we follow the EU water framework guideline, and as Sweden is in a Baltic Sea area, so we have the Baltic Sea Action Plan. The guidelines are very stringent when it comes to the different parameters. If you see, industrial wastewater has a lot of different parameters such as heavy metals, then the temperature is extremely high comparatively normal sewage, and there are different other characteristics which we have to consider when it comes to the wastewater from industrial side. If you see in Sweden, we have the ZLD much before, and now I see the India is gaining a momentum in zero liquid discharge. That is wonderful to see, but you need to have a right framework, institutional framework and policy to implement, and have a right guideline around it. As professor and both the professor said that we need a right guidelines and right characteristics characteristics. So we follow a very stringent parameters, and I feel in today's situation MBR is the solution. Veolia would be happy to hear that, but yes, it is the solution. And then there are different technologies. Of course, we should know what is the end use of this industrial wastewater. Are you going to recirculate? My focus would be on closing the loop. It should not go out of the facility. So it should be circulate. So what is the end use? Are you going to use for a gardening? Are you going to use for a, again bringing back to industry? Upon that you can decide on a technology. Electrocoagulation is a technology we are testing and we are accepting in India because chemical organics is very hard to break down, but electrocoagulation do that to break down on the pharmaceutical residues, microplastic, etc. Then the innovation part I want to mention here, as industrial wastewater has a high temperature, and we are investigating how could we use that hot water's energy to make your industrial wastewater treatment plant energy neutral. I have started one project in Delhi to recover a waste heat recovery from the medical waste incineration plant. Same we can do in industrial wastewater treatment plant or a normal wastewater treatment plant. We are also in a discussion with Navi Mumbai on that. We need a lot of digitalization. In Sweden, our focus is on digitalization for real-time monitoring and optimization to give the early warning. And the list is long, but I will stop. Thank you.
Thanks. You have given a good input from the particularly Western countries, and that too from the Sweden. So definitely it will be helpful to all. Now after that first round of question, Dr. Kulkarni talked about various discharge parameters and all. So with that discharge parameter, definitely some designing aspects are also there. So my specific question to you is what, in industrial scenario in India, what cost-effective solutions do you suggest for treatment of industrial effluent? Maybe a brief, we have to restrict timings.
Yeah. So very good question, because ultimately what matters is the money.
Now it is a solution part.
Yes. So what matters is money, and as you asked me, what are the cost-effective methods? So when we talk of cost, it is very important to know what cost we are talking. So there are two types of costs. One is the capital expenditure and another is operating expenditure. So most of the times, typically from the Indian perspective, we are mostly focused on the capital expenditure. So that attitude we have to change, because when we go to purchase AC, we purchase which is the minimum cost. But if we consider the electricity bill, actually the different other ACs which initially cost more, if you consider the 10-year period, they are the cheaper, which are costing initially more. So these aspects like machine learning, for example, energy conservation, we don't consider at all in the designing, and then it results in very high cost when we consider operation as well as capital expenditure. So now everybody is talking sustainability. There is Bureau of Energy Efficiency. So there is a lot of awareness is happening by which we are talking about the operational cost. So there are motors of categories IE3, IE4. They may be a little bit costlier, but purchase them, so the end user cost will be lesser. So energy conservation, designers like to design for safety, conservation design. So if you require say 5 kilowatt motor, you design for say 7.5 kilowatt. So what is the result? the motor works only just 30% loading, and that results into then you have to operate damper to again reduce the flow rate. So that increases your energy cost. So all these aspects, for that you require to hire a consultant, right? So again, Indian mentality is that, why to appoint consultant and pay him 2-3 lakhs rupees, 5 lakhs rupees? Directly appoint contractor. But what happens is, you end up spending 3 to 4 times more. So there is one example, I don't tell the names, two STPs. One STP cost without consultant, directly contract is given. Another same industry appointed consultant. The cost was less than 1/3 when the consultant was appointed. Because he gives the proper solution based on his experience. And the last is I know there is shortage of time, but there are certain ways, of course, like for example, you can split the civil works and mechanical and electrical works. Because civil works are standardized, right? So you can give your local contractor, or even you can do departmentally, and then again the cost gets reduced. So these are the various ways which I think holistic considerations you apply. Cost of land, for example. Bombay, for example, land is very cheap, so very highly costly metro cities. So there comes like Veolia, like technologies where the footprint is less. No tertiary treatment, no pressure sand filter is required, no activated carbon is required, just membrane and then reuse, right? So cost of land, because you have the plant in 1/3 of the land, right? So these are the various options you have to use, and you have to optimize the cost. That is my answer.
Thank you. So after listening to your answer, Rupali is very happy. Yes, happy, very happy.
More people like this, so I will get more.
Yes. So, but anyway, to conclude, he is talking about not only say capex, but you have to think about the operation and maintenance aspect also, and repetitive cost. So life cycle cost we can consider, and that is the requirement. So coming to the say operation and maintenance, the effective operation, efficient operation. Now with that particular thread, I am going to Mr. Kamal Tiwari. What steps are needed to make the STP more effective in terms of performance and efficient in terms of resource utilization?
So thank you, Dr. Salvi. So like I will take from where Dr. Kulkarni left. So if you look at, first thing we need to realize that if you take a decision of buying a STP, you have to live with that STP decision for a long period of time. It is not the asset which you are going to buy and maybe change every year or two. You have to live with it for at least 20-30 years. So you have to look at whole life cycle of the product. You have to also look at it is a device or technology which is mandatory as per compliance, and compliances are evolving. So you have to have those mindset in clear. And third, you need to first look at your performance criteria and then compare technology. Because even in the STP, even for STP in terms of, let's say due to lack of clarity, even NGT norms are applied for a smaller STP. Which means you are talking about a very high performing device which is able to remove BOD, COD to almost very high extent, and also nitrogen and phosphorus. So when you compare technologies, there are only very few alternatives are available in the world. So first thing is you have to define what performance are you looking at. The other thing which we feel, because we have been working with decentralized solutions, that conventional way of that you look at your futuristic demand and then you estimate that demand today and then you install a futuristic capacity from the day one. In our solution, we say that it is not required. You build your capacity for today and you can modularly increase it as your capacity increases. So that is one way to maybe optimize your investment from the day one. And you can also keep upgrading the technology going forward. Now, the other thing is, when particularly I will say for smaller and medium STPs, where the solution need to be robust and simple. If you add too much of technology which you don't have a skilled manpower to operate, then finally you end up either having a faulty equipment or you have, let's say, a very high cost to run or maybe correct the system. So in our system, we ensure that the systems are very robust. I would be very happy to invite you to our stall, and we have now good experience of thousands of those plants. So my prime thing is we need to look at design. then you need to have a contractor who can implement it properly, who is skilled, and then maybe the operators who are able to maintain it well, because you will have to live with the equipment for a long period of time. Yeah.
I agree with you, because really speaking, the operation and maintenance are problematic, so we need a simple solution. And I agree with you also that modular designing will help us. So that is what. So after talking about all these aspects, let us not throw anything outside, so that obvious solution is what ZLD, and automatically the panelist I can select is Mr. Ajit Khandeshe. So my question to Mr. Ajit, how ZLD be effectively implemented in industrial effluent treatment?
It's a very good question. First of all, ZLD is good or bad, which is debatable. We can go on debating for hours, and I will like to give a very good example which I have faced in my life. One ice cream manufacturing facility was given zero liquid discharge by the Pollution Control Board. Now, can we have recycling of water for manufacturing of ice cream? Because it is just impossible. You cannot take that water. When I was representing for Common Effluent Treatment Plant at the MOFCC, Ministry of Forest, for pharma industry, I requested them that you should allow a pharma industry to add one product named water, because they cannot recycle back the water in the process. It is very difficult, it is not possible, which is impossible. Madam was saying that internationally, yes, she is also agreeing that it is not possible. 100% recycling is not possible to the process. Possible, yeah, she is saying possible. But okay, there has to be some technologies to be adopted in Indian context. Conventionally, we have the treatment which is primary treatment, followed by secondary treatment. Tertiary treatment, when it goes for recycling of ZLD, it should be a membrane, or submerged ultrafiltration be a good technology. You should have a lesser evaporation. That is the reason we should have a RO which will have more recoveries. Maybe CCRO is one of the good technologies coming up. And then MVR based zero liquid discharge, which are the good technologies. But okay, with the time, we will know whether it is possible that we can have ZLD 100%, which is, I think, is a doubt, because again we have to control the carbon also. So all those things needs to be taken care of very properly.
Okay, so generally there is a question mark from the Ajit Khandeshe side. So we can have answer from Girish Bhave. So my question is what steps should be taken to make ZLD more sustainable? So whatever question posed by him, you have to give the answer.
Okay, that's a good one. So I think when it comes to ZLD, let us understand what is ZLD. I mean, everybody knows, but just on a lighter note, you can't discharge any liquid waste out of the factory premises. So that's fundamentally is a zero liquid. So what actually goes out is maybe in the solid form, powder form. Now the question is how you make it sustainable. So first of all, any industry person, whether it is by choice or by force. So 99% I think the answer would be by force. Nobody would really like to put a ZLD because it is not really adding to your productivity. It is compulsion by the the body, the regulations are making it. But ultimately the whole objective of putting ZLD is that you are actually recovering the valuable resources. So the first and basic thing for a ZLD, I think, I always feel, not because everybody should use Veolia technology or Veolia company, but what I mean to say is that if there is a greenfield project, can we look at it in a holistic way? A company who can really do a proper feasibility, that means a mapping of the whole unit operations that will go inside the project. Because it is always becomes a blame game. Somebody else does the pre-treatment, then a tertiary, and then the ZLD will be done by somebody else. And it becomes always a passing the parcel. So in today's situation, there are a lot of good companies, including us being a leader, who can really design a nice ZLD system by doing a proper mapping. Because what happens, you get different types of streams in ZLD, unfortunately. So it is very difficult. You have to do a characterization depending on the different composition of that effluent, which is going to enter into your flow sheet. So this is the first step, I feel, that proper mapping, doing a proper feasibility of the scheme. If possible, can we have a segregation at the source? That means there could be possible, there will be some light TDS, heavy TDS, there could be a mixed salt. So again, it's a combination. So as far as possible, if segregation can be done, that would be a good way where you can really try to knock down, the tough to treat effluents, treat it in a different way. The very other important aspect, the person should be really knowledgeable, because ZLD is the last unit operation in any industrial project. So how you can maximize your recovery in the upfront? And nowadays, you all have advanced technologies. You can use membrane based, you can have RO, 2-stage, 3-stage, even EDR is also there. We can use EDR technology and try to increase the recovery as much as possible. So what will happen, your last unit operation, which would be like a evaporator and crystallizer, will be having a very, very low flow rate. So you maximize your recovery and reduce the capacity of the ZLD. That's a very smart way of designing a ZLD system, which will really bring the capex low, opex low overall. Use energy recovery devices. You have now steam based, you have electricity based. Depending on the composition, availability in the specific premises, smartly design the system. Third, very important, lot of ZLDs are not working in India, and we see sometimes these are just like a showcase, plug and play. Sometimes whenever the PCB guys are coming, they just try to operate. So select right chemistry, use proper design techniques, have a proper continuous monitoring, maintenance is very, very essential. These are very fundamental things. And last but not the least, can you change the source? Going back to my previous question, can you use basically a sewage, treated sewage, as a feed instead of fresh water? Another way is also, some of the ZLD plants, when you design in a smart way, can you recycle the entire back into the feed rather than passing it into the utility? That means automatically you will curtail the fresh water getting inside the project. That's another area. And last but not the least, I think it's an event, okay, and it's a big drive as a ZLD. So as all technocrats be sitting on this podium and all the industrialists, they should look at it as a responsibility rather than a liability. Thank you.
So Girish Bhave has suggested certain things. Definitely still some question marks are there, so it is better to go to Professor. That will be better, I think. So my specific question is what, sir? There are some ifs and buts are there. Somebody is saying yes, if, but, so many things. So my question is what? Sir, role of research activities. Role of research activities, training programs and educational initiatives to realize the real circularity. You can say ZLD circularity in industrial effluent. So what is your suggestion?
Yeah, again now lastly it has come to me, and after that I think Dr. Salvi is going to conclude it. Majority of our workforce in the form of the technical people, it comes from the tier 2, tier 3 institutes. We have a huge requirement for the technical workforce. We all are, majority of us are engineers over here. All are not that lucky to get admitted to tier 1 institutes like IIT or VJTI. The institutes which are the premier institutes technically are having a research base. They get enough of support from the industry, they have enough of research facilities available, and a huge funding is available with them. So those who are trained over there are in normal course lucky to get an exposure to such kind of advancements. But what about the majority of the workforce which we are having? So we need to connect them, and there is a very strong connectivity need between or among tier 2, tier 3 institutes with tier 1, which is going on, which is very much over there with Government of India's a solution which is given. And in the new education policy now, the need on this is emphasized a lot. Now the industries, when they are talking about the various, the comparison which I was hearing and talking about the technology X and technology Y, if you will ask me, we need to compare, our title is cutting edge innovation. What is cutting edge innovation? Whenever we are talking about technology X or technology Y, there are definitely, it's not only the pluses which are over there are a number of minus is also there. We have to have an integration of the best combination, and that gives us, we have to analyze all these problems. When we talk about the sustainable development, it's the economy, and second is social, and third is environment. Now environment has come on the top, and we have to have the integration in this fashion that if the technology X is top, what are the implications and to what extent it is affecting to the environment. And that is why it's a challenge when it comes to talk about, search about a new technology. You are seeing here, these many stalls over there, everyone is trying to propagate that my technology is this, my technology is this. And as a technocrat, it's your responsibility. As a policymaker, it's policymaker's responsibility, and as an academician, where the research is there, it's my responsibility too. So we need the support from the industries for those who come from the tier 2 institutes, tier 3 institutes. Take the academicians. Academicians also need to be trained. The teacher is to be trained. He needs to be researched. He needs to be from the research environment. Otherwise, how is he going to give it to his students? And then when our workforce in the form of technical manpower comes out, we require 10 years, 12 years in the industry to train him. That gap we need there some kind of solution. So sir, research when it comes to, it needs to be definitely there with all types of institutes which are over there. There is a strong need for the academicians to be trained with the tier 1 or the higher premier institutes. And there is also a need that the industry comes forward and takes them, treats them as trains them so that they train your workforce power, the workforce which is over there. So I don't see that the institutes and the institutes masters and the PhD students coming over here. Ideally, if you visit to any of the international such kind of fair, you will find that the technical force, which is the budding engineers, they visit to them. But my concentration over here is the industry. If I go to a stall, if my student goes to a stall, he is treated in a different way than an industrialist or one probable client is reaching to them. We have to change our lookout. Yes. We have to be very much helpful because the academicians and the academic institutes are giving you the workforce. You are wasting your, I don't say wasting, you are investing your 10 to 12 years in an engineer. So you have to train them in time. And that is what is required.
Yes, thank you, sir. Very well, sir. So finally, waste is very important, and that comes from educational institute and training and skill development and so many things. So after a nice interaction, last but very important question to Rupali again, that is how industrial wastewater treatment be aligned with the principles of circular economy, and what the role of Western world is playing in driving this transformation. Again, I expect some inputs from the Western country, but be specific, madam.
Yeah, thank you. I totally agree with Professor what he said. What we do in Sweden, academia, industry and public sector work together to bring the solution on a platform. And that's why we are very successful and we are progressing. What I feel, there should be a multi-faced approach to bring the sustainable or to build a sustainable society with respect to wastewater or waste, anything that is stability, adaptability and proactive planning. So now coming to Mr. or Dr. Ajit Salvi's question about how we can align this with the circularity. Actually, I want to be critical here. There is a possibility that 100% water reuse is possible. what I feel, I don't know who said, but MBR is not the end. You can add a polishing step to it, like activated carbon is very, very important, followed by UV for the potable water reuse. So it is very important what end use we are planning or setting in our mind. Mindset, we have to work on a capacity building. We need to come on this in this climate emergency. And how we can align this, many times what I have seen, circularity has a 4 pillar: reuse, recycle, reuse, recycle, reduce are these 3 pillars we always remember. The most important pillar of circularity is recovery. That's what we have to focus on. ZLD, Professor or Mr. Ajit said, ZLD is impossible, or ZLD has some flaws, or I don't know if it will be a reality. I feel it is a reality in Sweden. Why? I know ZLD is very energy intensive. Nobody talked about it. It is an expensive thing. We have to see, as Kare mentioned, how we can lower the OPEX and CAPEX. There is a solution. Just work on a renewable energy to run your ZLD. What we do, as I mentioned, wastewater, industrial wastewater as a hot, it's very, very high temperature. Use that energy to run your ZLD plant. And it can be a circularity. We have to close the loop unless and until we cannot develop the society which is sustainable and climate resilient. So we all have to agree or disagree, I don't know. Nothing is impossible, as impossible itself says I am possible. Thank you so much.
Yes. Very nice, madam. Okay. So, first of all, she nicely explained what is the really difference between the Indian thought process and Swedish thought process. That will definitely help us. Before I conclude the session, considering the constraint of the time, I can only put only 2 questions. Participants, any 2 questions? Okay. Yes. So please, specific. Try to be specific. Please introduce yourself and a specific question to any panelist.
Thank you, Salvi sir. This is GK Arora from Engineer Technologies. I first of all say thanks to Professor Bhave. Basically, we are into industry and we work with academia. We develop the product for society. It's a need of today. Second point is, it's a question after that, thanks Lord. Ajit sir, why we advocate centralized CETP, means common effluent treatment plant. When cluster is there, yes, it's good, but mixed industries are there, we should discourage this phenomena. Reason being, quality of treatment may not be better as we supposed to each and individual industry can do, because they can again reuse, so they can maintain initially whatever the discard, primary treatment properly, secondary treatment, tertiary treatment, and they are supposed to utilize. After this CETP, nobody take risk and nobody take back for the reuse. Thank you.
I would like to answer your question in what has happened in small industries does not have the technical expertise. That is the reason common effluent treatment plant came in picture. Everybody is thinking that they have to drain out. Now in small industries, the flow is less than 25 cubic meters. So to have such treatment plant at their side and recycling and reuse, it's just impossible, because they have to again make some profits out of the process what they are doing in the manufacturing. So it is very difficult on the and the land parcel what is available for them is also small. That is the reason there is a limitation that up to 2,500 COD they can discharge to the common effluent treatment plant, small scale industries, and the flow around 25 cubic meters. So all those limitations are there. If you are more than 25, yes, you will have to have a complete treatment plant at your end. Recycling, reuse, there are technologies, there are upcoming technologies. Yes, it is possible that we should use it. There are so many examples we executed where the membrane process is being used on the effluent treatment plant and common effluent treatment plant. But it is possible. Again, the technology selection is major challenge. So it is always better that you should go, when it is a cluster of similar type of industries, one should have a common effluent treatment plant. That will be my suggestion.
Okay, one more question, please. One more question. Otherwise, panelists are available. You can definitely discuss with them of the times. Okay. I think there was a very nice discussion, and you will find that there was something, yes, no, ifs, buts, but definitely there was a solution also. And as the panel was formed very effectively and very intelligently, and even questions were also selected based on the requirement. So there is a good output, and we can say that on the one side, everybody agreed. So what are the treatment standards? Why it is needed, particularly industrial effluent? What are the complexity? Why treatment is needed? What standards are required? How ZLD can be implemented? What operational guidelines are required? And then apart from that, what Western countries are doing? And very important, research is required. Education is important. So that is what all activities, all various sites were discussed in a depth, maybe within 1 hour, but it was rightly discussed. I hope that it was a nice discussion, and I extremely thankful to all panelists for their time and their inputs. Really, it was the insightful inputs. Very thankful to all. Please have a good round of applause for